Better. So welcome to our YouTube channel KRIDHU. Today we are going to see the second problem based on the Bernoulli's equation. If you not went through our previous video, that is Bernoulli's equation concept explanation and how to solve that explanation, then I'll keep a link in the description box. Please go through it, then only come to this. Because if directly you come into it, you may not able to understand it. So now let's start our problem. Okay. So this is the problem number 2, by the way. First problem I kept with the previous video only. You can go and check there. So second problem is we taken is x square by cube plus x by dy minus dx equal to 0. So here if you observe, this is neither in linear differential equation or nothing you able to understand. Because here we taken x square by cube plus xy in a bracket, that is multiplied by dy minus dx equal to 0. So first step what you have to do, you have to move this dx other side. So here like this equation will come x square by cube plus xy dy equal to dx. This equation will come after shifting the dx. Now after shifting the dx, what we have to do? We have to make it dy over dx. So making of dy over dx means what? Actually, if you move this means it will become like this dx over dy. So here firstly what will come? Firstly, if you're moving dy other side means it will come like dx over dy instead of dy over dx. This will come. So after reversing it, dy over dx means it will be 1 by x square y cube plus xy. This will be the expression that we getting as a dy over dx. dy over dx getting is first step of making linear differential equation is completed. Because if you check linear differential equation and starting first, this either dy over dx or dx over dy is given like this. So now we have to convert it into linear differential equation, this one equation now. So we have to this is a universal rule that to form a linear differential equation, we have to send the lowest power out of this lowest power function like this xy to the side of dy over dx. So we done that only. So now normally like this we sending is not possible now. In this form we can't send. So we have to convert it into normal, uh, like not in fraction. It should be in normal equation, polynomial equation. So for that we done this reverse dx over dy we done. So here this you see dx over dy it is minus xy because this term came other side now. Xy term, this term came other side. So it became minus xy equal to x square y cube. This one left. This is the equation first, or we can say our linear differential equation. Now here this arrow mark is on x and x. Okay. Now first step we're doing to solve the linear differential equation. Like previous video, if you'll go miss, we are dividing by the 1 by yn or 1 by xn as per our this value, this dx over dy value. Here dx over dy means we have to divide by x square. Like whatever term given here, highest polynomial of the same term, we taken the differentiation at the first. Okay, so x square we have to divide. If here dy over dx means here by cube we have to divide. Now here dx over dy means x square we have to divide. So it will be divided by x square in equation number first. Equation number first we dividing. So 1 by x square dx over dy minus y over x, because here x sum already one x sum in first equation is present, so that cut it equal to x square cut it, so y cube. This is we got equation number 2. I think you understood. We divided x square in first equation number first. So here firstly dx over dy means 1 by x square dx over dy became minus x over y, means what you will get minus x over y minus xy present over x square you write it. Now this square will cut with x. Not only here done, so y by x we got equal to y cube because here x square present. That x square got cut. This we taking as equation number 2. Now let what we assumed, this minus 1 by x term we assumed as b. This is equation number 3. Now you know 1 by x differentiation what? 1 by x differentiation is minus 1 by x square. So here already one minus is there, so that minus minus we can place. So 1 by x square dx over dy equal to db over dx, that is equation number 4. Normally we differentiated once again in the equation number 3 to get the db over dx. So this should become 1 by x square dx over dy. That is matching to our equation number 2, this dx over dy. Okay. Now the values of equation number 3 and 4 we keeping in the equation number 2. So what we getting now, dv over dx plus by equal to y cube. Why we got like this means previous I said no, 1 by x square dx over dy is equal to db over dx plus by means minus 1 by x we taken as b. So by equal to y cube. This is our equation number 5 and it is a perfect form of linear differential equation. So we can solve it now as a linear differential equation. So step 2 is find if. If means integrating factor. I think you guys know integrating factor. So here it is dx over dy. So integrating factor formula is if equal to e power integral p dy. E power integral p dy. Okay. This is because there is dx over dy. So here e integral p value what by we have it. So e integral by dy equal to if. So if value we getting as e by e power y square by 2 because integral of y is y square by 2. Next, now we solve finding the solution of equation number 5. So for that we have formula b into if. Like this is the form there to find the solution of equation number 5. So that is b into if equal to integral in bracket q into if dy. It's so simple. So now b into if value we kept here equal to integral by cube into ey square dy. By cube is our q. From the equation number 5 we will see. So b into ey square e power y square by 2 is okay. And equal to be separated y cube in y square and 2. We can make it now. This y square dot y. We can convert it. It's no problem. So as we converted it means y square dot ey y square dy. So what we done, we taken y square by 2 equal to t. Y square by 2 we taken as t assumed. So differentiating now y square by 2 with respect to dy. So what it will become 2y over 2 equal to t. So 2 got converted. So y is over y equal to t. We can write y dy equal to dt. From here we can see. Okay. As we substituted y square by 2 as a t. So here we'll get, because there only y square present, so 2t e power t, because y dy equal to et dt we got. So this is whole equation what we got after substituting the previous one. Okay. So now there is a fun formula which I shared in previous video also. See this. Integral x e power ex dx is what? Ex in bracket x minus 1 plus c. Same way applying here is b into ey square by 2 equal to 2 e power t in bracket t minus 1 plus c. Simple. So now we're substituting the value of b in this last equation. In this equation, substituting the value of b, that is minus 1 by x. And initially we taken, if you go back and you check, so we're substituting it and we keeping the value of t, that is t equal to y square by 2. So minus 1 by x e power y square by 2 equal to 2 e power y square by 2 in bracket y square by 2 minus 1 plus c. This is our final solution of this differential equation. So like, share, subscribe, comment for more updates.